Hello guys, welcome to a new YouTube video. Today we'll be talking about algebraic inequalities. Inequality is defined as a comparison of two or more mathematical expressions that are not equal to each other. So, for example, like x is greater than 3, which just means that it's bigger but not including the 3. And the same goes for less than, which is smaller than 3 but also not inclusive. But we have greater than or equal to, which is denoted as this. This is inclusive of the number 3 as well, and this is x is less than or equal to 3, so that's also included. When solving algebraic inequalities, the rules for algebra still apply. So still got to the bottom math, still everything still applies. Collecting life terms, all that, and we can denote this on a number line, for example. X is greater than, this just shows that x is greater than 1. So that anything that goes right of something, it means greater than. And the open circle denotes that it does not include a number 1. Okay, so watch out. Keep remembering that. And opposite of that goes this way. If x is less than, okay, there are important things to know. And once this, we gotta paint it in because it's part of, it includes the value 1. And the same goes with the opposite way. Because x is greater than or equal to 1. So I hope you guys understand this. So in summary, open equals not inclusive. Closed equals inclusive. So just remember that. The open is that includes. So I like to remember that, like, if it's open, you're not going to contain the 1. But if it's closed, it means the 1 is also included. So that's how I like to remember it. There's a specific rule when I said this. So obviously we know that 3 is greater than 2. So 2 is less than 3. However, there's a problem with inequalities once you get into negative numbers, when you multiply it by negative or divide by negative numbers. For example, I times both sides by negative. So that gives me minus 2 is less than negative 3. Which is wrong. Clearly, as you can see from the number line, there's definitely something wrong. So we're gonna flip this. And the same goes with divide. For example, if I divide by negative 1, this will be negative 2 is less than negative 3, which is not right. So you flip it. So for example, minus 3m plus 7 equals, no, not equals to, is, it also works for less than or equal to, or like even with less than or equal to, like, they're all the same. Is less than or equal to 67. 67! Haha, very funny. So I'm gonna minus 7 from both sides, right? We got 3m is greater than 60. But I just want to get m on its own. So I'm going to divide by minus 3. That gives me m is greater than negative 20. Alright, but we gotta do the flip. We gotta flip this around. So look at this. M is less than negative 20. So I hope you guys have the idea of this. And we will start solving some. So I'll go through question 2, 3, 6, and 7, question 10, and 13, 20, and 22. And there will be a separate additional video that will not be as long, covering inequalities as well. But you'll have to wait for the next one. So this one is very simple. We got 4x plus 1 minus 1 is less than negative 8. So this equals 0, so 4x is greater than negative 8. So we've got to divide by 4 on both sides is greater than equal to. Or greater than or equal to, so remember that. So we hold that in, and we go right. Alright. Question 3. So what I like to do is I like to read it in from the end on the left side, so because that helps solving this kind of easier for me. Is greater than negative 1. As you can see, it's greater than negative 1 because negative 1 is less than 2n plus 4 minus 5, so it's small, so that 2n plus 5 plus 4 minus 5 is naturally bigger. So you put this like this. Alright, you're gonna add these together, and we realize, oh, 2n minus 1 is greater than negative 1. And we're gonna add 1 to both sides. 2n is greater than 0. So when we halve it, that's just gonna end equal 0. So you get 0, include 0, and go that way. Question number 6. 2p minus 4p is less than negative 2. That gives me negative 2p is greater than negative 2. And we're gonna divide by negative 2. So you can just isolate p on this side. P is less than or equal to 1. But as we learned from that example from before of the minus 3m plus minus 67, and obviously we can see when you times something by negative 1, you gotta flip the sign, the inequality sign. So let's flip it, and this is answer. Alright, question 7. I'm gonna do the same thing by moving this to this side. We gotta distribute the negative symbol across. You get positive k plus 3, okay, plus 2 is greater than 7. So k plus 5 is greater than 7. Minus 5 from both sides. And what we get is k is greater than 2. So we have this, there we go again. Question 10. Minus 2 brackets b plus 1 plus 4 is less than 10. We gotta distribute this, and we get is minus 2b minus 2 plus 4 is less than 10. Then we go minus 2b minus plus 2 is less than 10. Minus 2 from both sides. Minus 2b is less than minus 8. And we divide by negative 2 from both sides. We get b is greater than, because you're going to flip it, sign, b is greater than 4. So far we only got, sorry, my bad, positive 8, so it's greater than negative 4. Next up, question 13. It's a bit complicated, but the same principle still applies. 26m is greater than or equal to 5 brackets minus 6 plus 3m. Okay. What we're gonna do is, we're gonna first distribute. So we get 26 plus m is greater than or equal to minus 30 plus 15m. I want to move this 15 to the side, so I'm going to minus 15 from here, and we get minus 14m, right? And I'm going to minus 26 from here, so the other side. All right, minus 26, minus 56, minus 20, and you're going to divide by negative 14 from both sides, which gives us 4. So m, and then we're gonna flip the sign, of course. It's less than negative 4. Sorry, malfunction. this less than, boink. That's how you do it. Question 20. 5x minus x plus 2 is greater than minus 5, 1 plus x plus by 3. That's a very good question. I like the way it's formatted. So we're gonna first distribute the minus symbol. So that is greater than minus 5. We're gonna distribute this minus 5x plus 3. So 4x, collect like terms, is greater than this minus 5x. Collect like terms. Minus 2. You're plus 2 on both sides. Now actually move this to the side. You're plus 5x. 9x is greater than, move the minus 2 to the other side. It's plus 2. 0 to 0. X is greater than 0. Hmm. 5x minus x minus 2 is greater than minus 5 and minus 5x plus 3. 4x minus 2 minus x minus 2. 9x is greater than 0. Any particular solution is so obviously you have to see 4x is greater than. This actually makes sense. This definition kind of like. Any value greater than 0, I think. Let's check 22. I don't know if I have a bad feeling about this one. You got it right. So thank you everyone. This concludes this video. So like the video, share this to your friends and peers, subscribe with the bell notifications, okay? And I hope you enjoyed this video, and I'll see you in the next one.